All right. For the next problem, we have a ball that's being bounced and the different heights that it's reaching, and they want to know what function best models the data and why. And here, the unfortunate part is we did not cover logistic functions. It's something that's studied more in calculus, and we didn't cover it. So I'm sorry about that. But logistic functions look like this, where they are following one asymptote down here and then one asymptote right there. And they don't decrease, they increase. And so we automatically know that those are two problems that we're not going to have. So the answers between part A and part B, it's an exponential function, which means that it's repeatedly multiplying by the same thing. And we could say it's decreasing by 25% or decreasing by 75%. So what we want to do is figure out how you get from one point to the next. How much does it decrease by? So what I'm going to do is I'm going to divide these numbers. I'm going to do 31.5 divided by 42. And the reason I'm going to do that is because it's going to tell me what I should repeatedly multiply by. So 42 times 0.75 is 31.5, times 0.75 is 23.6, times 0.75 is 17.7. So it's multiplying by 0.75 each time. Now you have to know how to interpret that. Does that mean that the ball is decreasing by 75%? Or does it mean the ball is decreasing by 25%? A lot of students would go with 75% because multiplying by 0.75 like matches, but that's incorrect. When you multiply by 0.75, it means you're keeping 75%. You're not losing it, you're keeping it. So if you're keeping 75%, it means you're losing 25%. So the answer is A. All right, number 10, find the inverse function. So I'm going to go ahead and trade my x and my y. And then I'm going to solve for y. So first I'm going to go ahead and add the 2 to the other side. And then to get rid of the exponent of 3, I'm going to cube root. So the cube root of x plus 2 equals y. And then I'm going to switch my notation to the inverse notation. And so that means that my answer is A. All right, what are the polar coordinates of this point? So we know that the r value is the square root of x squared plus y squared. And we know that theta is tan inverse of y divided by x. And we know that when we find it, we have to be careful about what quadrant it shows up in. So this is quadrant 2. And so we need our answer to be in quadrant 2. Okay, so I'm going to go ahead and figure out what my r is. I have -2 square root 3 squared. You'll notice I'm not doing this by hand, even though I normally would have when I was teaching it to you. And that's because this is a calculator active exam. And so, you know what? That was worthless. They gave you all those answers. Well, root 24 is 2 root 6. So the reason I'm not doing it by hand is because they gave us calculators, so you might as well use them. So we know that the r is 2 root 6. That doesn't narrow anything down. So now we need to do tan inverse of 2 square root 3 divided by -2 square root 3, -45. Now, -45 is in quadrant 4. Remember, to get answers in quadrant 2, you need to add 180 degrees. So 135 is actually the answer that we're looking for. So that's this one right here. Now, I would be careful. The kind of nice thing, I guess, that they did is they did not give you 315 as a distractor answer. It's over here, which is kind of nice that they didn't do that. because that would be like the common wrong answer if you used a calculator for this. So this problem is almost easier to do using a unit circle because you'd think it through a little bit more. But quadrant 2, the answer should be 135. And then if you look over here, all they did is they were thinking about like what's another way to name that exact same point. So they were saying, okay, the angle on the wrong side of the unit circle and a negative radius. So if we were to plot this point, we would say that it's somewhere over here, right? Positive radius, positive angle. And so they're saying, oh, if we use the angle over here, then we have to use a negative radius, so we're counting back that direction. So B is definitely the answer. Both answers are good, so they gave you the point you'd actually find, but they also gave you an alternate form for the point. Over here, we have the equation in polar form. We want to convert it to rectangular. So I'm going to take the denominator and multiply it over by the r. And then I'll distribute the r. And this should bring back very happy memories. These are the conics. So r is the square root of x squared plus y squared plus x equals 2. And the nice thing is they gave you, like, not a tough one. We did much harder ones than this in class. Negative x plus 2. So we would square both sides. And then if you guys remember, when we have this squared, that means we need to write it twice and FOIL it. So we have x squared minus 2x minus 2x plus 4. And then when we did it in class, we got everything over to one side and made it equal 0, but they left it equaling 4. So that just means we're going to take these two things and subtract them over, or add. So the x squared, when I subtract it over, it cancels out, and I get y squared plus 4x equals 4. So not only do I know the answer, but I know that this would be a parabola. A sideways parabola. It's got a y squared. Sideways parabola would go towards the right, I believe. Left. Anyway, that's number 12. Fun, fun.